What would the plot look like for the probability density function? Well, you just square your plot, right? Probability density is just psi squared. So let's plot psi squared for n equals 1. What would it look like? From x equals 0 to L. First of all, what should it look like below, at x less than 0? It's going to be 0. Psi is 0 here outside the box. Psi is 0 here outside the box. X equals L. So for n equals 1, what was our psi? It's just half a sine wave. So what happens when you square that? You just get a bigger, this is a square. So it's going to look like that. And it's going to be bigger if that number, if that peak is larger than 1, right? It's going to be smaller if it's smaller than 1. But that's going to be what? What's that peak value there? What's the square of 2 over L? So this is just going to be 2 over L right here at the peak. Okay. What about for n equals 2? From x equals 0 to x equals L, n equals 2, so psi 2 squared, absolute value. What would you get now? Again, it's 0 at x less than 0, 0 at x greater than L. 2 humps. And what do you call this thing right here at L over 2? That's your node, right? Even though it goes from yeah, it's still, because the node is based, the definition of the node is based on psi itself. Okay, so that's the node. 0 inside the box is the node. And psi is 0 inside your boundaries. Yes, that's a node. Yeah, and that's when psi. And those are generally cases where psi crosses over from positive to negative or negative to positive. But in this case, it doesn't. Well, this is psi squared. Oh, all right. Psi still crosses over from positive to negative here. Psi is still 0 at the node here. What you're plotting here is psi squared. Okay, what would be the integral if you want to determine the probability of finding the particle in the middle third of the box? What's the probability of finding it in the middle third of the box? What would your integral be? What would be your limit? Your box goes from 0 to L, so where's the middle third? So what is this location right here? This is L over 3, 1/3 of the box, right? This would be 2L over 3. So this is the left third. This is the right third. Where's the middle third? This one right here. So what will be your lower limit? From L over 3, oops, L over 3 to 2L over 3. And what is it you're integrating? dx psi squared, right? Absolute value of psi squared. Let me write this. Absolute value of psi squared dx. Well, let's plug in those numbers. Let's plug in the function. So that's going to be integral of limit L over 3 to 2L over 3. What's my expression? Square root of 2 over L times sine n pi x over L. But what is our n according to the question? N equals 4. So you need 4 pi x over L. You square that and then dx. Okay? Now, given that that plot looks like this from 0 to L, there's a node here and there's a node here. That's n equals 4 would have how many nodes? Oh, sorry. N equals 4 has how many nodes? 3 nodes. So you're going to have equally spaced nodes. So you're going to have a node at L over 4, at L over 2, and 3L over 4. A node there, a node there, a node there. So you're going to have 4 humps, right, in your chi-squared function. That one, that one, that one, that one. So in the middle third, what is this integral equal to then? That's that area from L over 3. Where's L over 3? Somewhere here. And 2L over 3 is somewhere here. This area right here. That area under the curve is the probability of finding it in the middle third of the box. You think that's going to come out 1/3? Now let's see. Let's verify using math. Integral from L over 3 to 2 times L over 3 of square root of 2 over L. Oops, what did I just do? L times sine 4 times pi times x divided by L. And the whole thing squared, right? I don't have to worry about absolute value there since it's real dx. I'm going to evaluate this symbolically, and there's my expression. What is that equal to? That's the exact solution. So I'm going to copy that, and I'm going to ask MathCAD to tell me what that number is. I'm just going to hit equals, and that's 0.402. So there's a 40.2% chance for if the particle is described by psi with n equals 4, there's a 40% chance that it's going to be in the middle third of your box. Okay? Okay, what happens to the probability of finding the particle in the middle third of the box as n becomes very large? What do you think is going to happen? What happens when you have more? The larger the n, what happens to the number of nodes? Increases. So if as n, let's imagine what happens as n approaches infinity. What's going to happen? You're going to get so many nodes, right? They're so very closely spaced nodes. Huh? Yeah, you've got these really short sine waves between 0 to L, right? So what happens, what ends up happening is as n approaches infinity, that area right there under the curve for psi squared versus x, that area right there becomes essentially 1/3 of the total area. So that limit, okay, the limit of that would be, okay, as n approaches infinity, it's going to approach 1/3. It's going to be 1/3. Okay? Now, if if I were to ask you what would be the probability of finding it in the left half of the, that's from, let's say, from 0.1 L to 0.2 L as n approaches infinity, it would be 1/10. That would be 1/10 of the entire length of the box. But for finite n, for small n values, that's not going to be necessarily the case. But that's what you'll get as n approaches infinity. And there's a